Hello, Morehouse. Welcome to Hello, Morehouse. Welcome to today's math lesson. I miss you all so much, and I hope you're doing well at home and keeping safe and healthy. Today we're going to be working on Module 5, Lesson 25. This has been a super long module. We've been studying fractions for a very, very long time, and I know you are all getting better and better at math, and I'm so proud of you. Today we're going to be working on, like I said, Module 5, Lesson 25, and our objective is to express whole number fractions on the number line when the unit interval is 1. So we're just going to continue taking our math knowledge to the next step here. We're going to do our guided practice on our own using Math Chat, and then your job when we're done is going to be to complete the fluency practice with Number Gym and Sprint, and the independent practice with Tower of Power. All right, let's get started. Sign in here with Google. All right, let's begin.
Hey, Math Star, let's learn.
Partition into thirds, then shade the whole. So we want to split this into thirds and then shade in the whole thing. Write the whole as a fraction in thirds. 3/3 equals 1 whole. Partition into halves, then shade the whole. So halves, we know there are 2 pieces, and now we're going to shade in the whole thing. Write the whole as a fraction in halves. 2 halves equal 1 whole.
Kayla?
I split the first rectangle into 3 equal parts to make thirds, and shaded all 3/3. 3/3 must be equivalent to 1 whole. I split the second rectangle into halves and shaded both halves. So 2 halves equals 1 whole as well.
You got it. Keep going.
What pattern do you notice in the fractions we've written so far? How would you label the last rectangle as a fraction? So far, I've noticed that the numerator and the denominator, or the top number and the bottom number in each fraction, is the same. So with the last one, there's only one piece, right? That whole is not divided into anything else. It's just 1. So it would be 1/1.
The first 2 fractions have the same number on the top and bottom. This last one just had 1 shaded piece. So maybe it's 1/1.
That's right. 1 whole is equivalent to 1/1. We didn't split the whole into more parts, so it's still in 1 piece. And that 1 piece is shaded, 1/1.
This rectangle is partitioned into thirds because there are 3 pieces. Now partition the number line the same way. 1, 2, 3. Label the fractions in thirds that represent the whole rectangle. The whole rectangle is going to be 3/3. It's going to have the same numerator and the same denominator.
Kayla?
The rectangle is partitioned into thirds, so I partition the number line into thirds as well. To represent the whole rectangle, I can write 3/3, which is the same as 1 whole.
Nice. Let's keep going.
Partition this number line the same way as the rectangle. That's in halves, so I'm partitioning my number line into
This
halves.
rectangle shows 2 halves, so I partitioned the number line into halves. I can rename 1 as 2 halves since they're equivalent. The last rectangle has 1 piece in total. So I didn't need to partition the number line. It already shows 1 whole. 1 whole is equal to 1/1.
Great.
Why didn't we partition the last number line? How did we know what fraction to label the whole? I want you to think about this to yourself. Why didn't we partition the last number line? How did we know what fraction to label the whole?
We didn't need to partition the last number line because the rectangle is just 1 whole, and the number line already shows that. It's 1 piece, and we're counting that piece. 1/1.
Excellent. Great effort so far. Keep it up for this next one.
Each rectangle represents 1 whole. There are blank holes in this model. 1, 2. There are 2 holes in this model. Partition each hole into thirds and shade each hole. Partition each hole into halves and shade each hole. Shade each hole.
Each rectangle is one hole, so there are 2 holes in each model. Here, I split each hole into 3 equal pieces to make thirds. Here, into 2 equal pieces to make halves. And we don't have to partition this model because they're already holes.
Right you are.
Each hole is partitioned into thirds. There are 2 holes. Label the model using thirds. All right, so now I need to count all of the pieces in the model, not just what's in one hole. We need all of the pieces. So using this model, I know that I have 1, 2, 3, 4, 5, 6 pieces, but in each hole there are only 3. So that's what's going to go in my denominator. Label this model as a fraction. So again, the numerator is how many pieces, how many parts are shaded, right? So there are 4 parts shaded in. And the denominator is going to be how many parts there are in just one of the holes. And there are 2 parts in each hole. This model has blank copies of blank hole. How many holes are there in this model? There are 2 copies of one hole. Label this model as a fraction. 2 copies, right? There are 2 pieces that are shaded in, but there's only 1 piece in each hole. So 2 over 1.
This model has 6 thirds shaded, so that must be equivalent to 2 holes. Here there are 4 halves, and it's also equivalent to 2 holes. And the last one has 2 copies of one hole.
Right. The top number is the number of copies we have, and the bottom number is the unit. So here we can write 2 over 1, because we have 2 copies of one whole.
All right, we are going to go on to our problem set together. So you're going to want to open up your workbook to the lesson, what lesson are we on? Lesson 25 problem set. I'm going to go here to my lesson 25. All right, you might want to pause that while you get your workbook out, and then we're going to work on this together. Press play when you're ready to continue. Number 1, label the following models as a fraction inside the dotted box. Label the following models as a fraction inside the dotted box. The first one has been done for you. So, 1 whole is equal to 3 thirds. Now we want to, sorry about that. My son came in here trying to talk to me. We're going to write down what this fraction is. So, draw our fraction line. There are 2 pieces in each of these holes, but 3 pieces are shaded in. And for this one, we have 1 piece in each hole, but 3 are shaded in. So 1 hole, and we saw that 1 rectangle is equal to 1 hole. I want you to take a minute to do the next 2 on your own and then check your work to see if it matches mine. All right. So for this next one, we have 1, 2, 3, 4 pieces in the hole, and all 4 are shaded in. That would be 4/4. Next, we have 2 pieces in each hole, and 4 of them are shaded in, so we have 4 halves. And this next model, there's only 1 piece in each hole, right? It's just the hole. It's not divided into anything. 1, 2, 3, 4 holes are shaded in, so it's 4 over 1. Finally, let's move on to the last row here. We have 8 pieces in each hole, and all 8 are shaded in. Next, we have 3 parts in each hole, So that's going to go in the denominator. See 1, 2, 3. And 6 are shaded in. Finally, we just have one. See, there's only one hole. It's not split into anything. So that's what's going to go in our denominator. And we have 1, 2, 3, 4, 5, 6 shaded in. 6 over 1. All right, check your work, make sure it matches mine, and then let's move on to the next page together. Please feel free to press pause anytime you need a little extra time to catch up. Alrighty. Moving on to the next page. Number 2, fill in the missing whole numbers in the boxes below the number line. Rename the whole numbers as fractions in the boxes above the number line. So at 0, this is kind of a tricky one. We still have 0 over 1. At 1, it would be 1 over 1. At 2, be 2 over 1. Do you notice the pattern here? Each whole number is just that number over 1. 3 would be 3 over 1. 4 would be 4 over 1. 5 would be 5 over 1. 6 would be 6 over 1. When we write whole numbers, that just means that in this fraction, as a fraction like this, it just means that if you split each piece into one whole, you would need like 6 copies of that whole. So 6 over 1 means that you need 6 copies of the number 1, right? 1 plus 1 plus 1 plus 1 plus 1 plus 1. If you added 6 ones all together, you would have 6. Hopefully that's making it a little easier for you. Let's do the next one. 10 over 1, that number would just be 10. 11 over 1, that would be 11. Continue the rest of this number line. Hit pause while you work on it, and then press play again and check your work. All right, let's check the rest of our work. 12, the fraction for 12 would be 12 over 1. For 13, we would have 13 over 1. For 14 over 1, that whole number would just be a 14. 15, the fraction would be 15 over 1. And 16, the fraction would be 16 over 1. Finally, number 3, explain the difference between these two fractions with pictures and words. All right, take your time to do this and then press play to check your work. What is the difference between these two fractions? Okay, I always find it helpful to draw a picture first. Just like we learned in the beginning of the year when we solved word problems, we want to read, draw, write. We read the problem, now we're going to draw a picture, and then we're going to write our word sentence, right? So let's draw a picture first. 2 over 1 would be 2 copies of 1, right? This is 2 over 1. Now let's draw 2 halves. This is a picture of 2 halves. We have 1 half, and then here's the other half. 2 halves. See how these two pictures are different? We have two of one whole, 2 copies of one whole for 2 over 1. But for 2 over 2, that's 2 halves. We have one whole that's split into 2 pieces, and both pieces are shaded in. So I'm going to use words to write my answer now. 2 halves is 1 whole. 2 over 1 is 2 copies of 1 whole. That's how they're different. Okay, 1 is just both pieces shaded in, right? 2 halves is just both halves shaded in on 1 whole. 2 over 1 is 2 copies of 1 whole. So that's how they're a little bit different. Your job today is to complete lesson 25 on Zern and unlock lesson 26. If you need help, don't be afraid to reach out to me on Google Classroom or by giving me a call. All right. Good luck, everyone. I'm very proud.